Assumptions for fractional age. There are three assumptions that are widely used in actual science. They will be stated in terms of the survival function in a form to show the nature of interpolation over the interval x to x plus 1. What is fractional age? So normally in previous chapters, we always use the integer age in terms of, let's say, 20, 21, 22. So for this time, age is in terms of fractional. For example, x is equal to 20.5, x is equal to 21.75. So we use interpolation to find the fractional age over the interval x to x plus 1. So for example, x plus 1, let's say x equal to 20, so x plus 1 would be 21. So the fractional age may be in between x to x plus 1, so it can be 20.75. So we use the interpolation to find this fractional age within this interval x to x plus 1. X is an integer 0 to 1. The assumptions are as following. There are three assumptions. First assumption is linear interpolation. It is also known as uniform distributions of depth, UDD, where the assumption TPX is a linear function. So meaning that throughout the 1 year, the probability of survive is linear. The second one is exponential interpolation, or we call it as linear interpolation on log. So this is the equation for the exponential interpolation using log, with the assumption of a constant force. So constant force we already covered in previous chapter. Under this assumption, TPX is exponential. So the difference between linear interpolation and exponential interpolation, the TPX for linear interpolation is a linear function, and TPX for exponential interpolation is exponential function. And the last one is harmonic interpolation, or we also known as Baldacci assumption. So the TPX for harmonic interpolation is a hyperbolic curve. So the first one, linear interpolation, or also known as UDD. When we draw the timeline between 20 to 21, because in 1 year interval, so x plus 1, so x is equal to 20, x plus 1 is equal to 21. So t, the time of death, we are looking for the time of death is x plus t is 20.5. So the t here is 0.5. So Lx plus t is 20.5 equal to Lx is L20 minus t is 0.5 times dx. So dx is d20. So dx also can be written down using this equation. So in previous chapter, Qx is equal to dx over Lx. The probability of death from x to x plus 1 is equal to number of death from x to x plus 1 over number of survivors at age x. We get the second equation. Then we take out the Lx, we simplify this equation, we get Lx times 1 minus TQX. Second one, TQX is equal TDX over Lx. So TDX also can be written in terms of Lx, where it can be Lx minus Lx plus t. Lx plus t can be written in terms of the first equation. Then we simplify this, we can get t times qx. The t is not the small t in front of q. T is the value. So t is 0.5 in this case. So t times qx, the probability of death from x to x plus 1. So the third one, as you know, TPX is the complementary function for TQX. So TPX is equal to 1 minus t times qx. So it comes from second equation. Number 4, mu x plus t. Differentiation of Lx plus t over Lx. So the Lx plus t we can write down in terms of the first equation. Lastly, we get qx over 1 minus t times qx. Number 5, this equation, if we draw the timeline, so the probability of death from x plus t to x plus 1. So the t become 1 minus t from x plus 1 minus x plus t. So we get this t. So it can be written down as 1 minus t times qx over 1 minus t times qx. So yqx plus t is equal to yqx over 1 minus t qx. From the timeline, from 20.5 to 20.8. So y is 20.8 minus 20.5 is equal to 0.3. For this interval. So then we plug in this equation. And the last one, for the TPX mu x plus t is equal to QX. According to constant force, the force of mortality within the year is same. So in this case, the example shown in this equation for age 60. So we change this into 60 to 61. So from interval x to x plus 1 is from 60 to 61. So the force of mortality from 60.1 until 60.9 is equal. For the force of mortality greater than 61 is not equal anymore, like the first equation. 61.2 is not equal to the force of mortality 60.1 to 60.9. So mu is equal to negative ln px. So px is equal to exponential of negative mu. So the first one for Lx plus t equal to Lx the power of 1 minus t times Lx plus 1 the power of t. Still in the 1 interval, x to x plus 1. And TQX is equal to 1 minus TPX t. So TQX is equal to 1 minus E negative mu t. Like the first case, in the UDD, we also have y, where in the first case is x is equal to 20, x plus t is 20.5, x plus y is 20.8, and x plus 1 is 21. So y is 0.3, the interval between x plus t to x plus y. Since constant force, the force of mortality is equal throughout the interval, so yqx plus t also is equal to 1 minus E negative mu y. So instead of t, it becomes y. So the last assumption is harmonic interpolation or Baldacci assumptions. So you can go through one by one. As it is a hyperbolic curve, so it uses this equation. Let's try the second example. Given this 65 is equal to 20. So first we try calculate using UDD assumption. So we have to find L 65.5. So this is Lx plus t. So we have to use the equation of Lx plus t is equal to Lx minus t times dx. So L 65.5 is equal to, so here x is 65, x plus 1 is 66, So T is, we are looking for L 65.5. So T is 0.5. So we substitute Lx become L65 minus T is 0.5 times D65. So we plug in the values into the equation. It becomes 100 minus 0.5 times 20. It becomes 90. So second assumption is constant force. So Lx plus T for constant force is equal to Lx the power of 1 minus T times Lx plus T the power of T. So L65.5 is equal to L65 1 minus T is 0.5 times 66 0. So the answer for all the assumption must be same. So the third one, Baldacci or hyperbolic assumption. So we substitute, so we get 89.889. So it is approximately to 90. So for B, when we draw the timeline from 65 to 66, and the fractional age is 65.5. So T is from 65 to 65.5. It is equal to 0.5. And Y is from 65.5 to 66. So Y is equal to 0.5 as well. So we can use the equation for Y QX plus T. So for UDD, so Y is 0.5 times Q65 over 1 minus 0.5 times Q65. So what is Q65? Q65 is equal to D65 over L65. So we plug in the values inside and we get 0.2. So then we plug in Q65 into this equation and we get 1/9. For constant force, so mu is 0.5 Q65.5 is equal to 1 minus E negative. Mu is 0.2231. Y is 0.5. So for the constant force, first you have to find the mu. So remember mu is negative ln px. Then you can plug in the equation. So for the third one, Baldacci, So the answer for all the assumptions are approximately equal.